Hello everybody, welcome. Last time we kind of finished up the sprite rendering class we had, and it's not completely done, but it's done enough for what we need to do. Later on we're going to complete it by implementing a camera system as well, but for now that'll be good enough for our purposes. The next thing we want to do is create a render target that will allow us to keep our screen resolution, our two-dimensional game screen resolution, regardless of what the user is using for their monitor or screen resolution. And we can take a look at what the idea is over here. So we can render our game to a constant screen resolution. Just pick a resolution that we want our game to run in. So for example, let's say it's a fairly low resolution, just as an example, 640 by 480. Okay, and this is where all of our game rendering is happening on this render target. And over here, let's just say this is the user screen, and we'll make that a little bit bigger. And just for example, we'll say they've got a screen of 1920 by 1080. What we want to accomplish here is now allow our game to run in whatever resolution we want, in this case 640 by 480, and then stretch it to fit the screen of the user, in this case 1920 by 1080. And so it'll center it, it'll find the point that is centered, so we'll just say it's here, and then stretch it to fit the screen as much as it possibly can. In this case, the user screen is wider than the screen over here, and so we're going to end up with some area over here that's not used and some area over here that's not used. But it'll stretch it to fit as much as we can. Let's go ahead and implement that in our code. Here inside the graphics folder, we're going to create a new item. And this is going to be a class that I'm going to call the screen. Trying to think of a good name for this. Well, let's call it screen for now. We'll go ahead and bring in the namespaces for monogame. This is going to be a sealed class, and it will implement iDisposable because we're going to bring in one class from monogame that's going to be available for disposal. And we can do that right here. This is going to be the RenderTarget 2D. And I'm just going to call this the target. Since we're implementing disposable, let's make a Boolean flag for isDisposed. I think I want to keep a reference to the game as well. That should be good enough to start. Let's go ahead and create the constructor. We're going to pass in a reference to the game class, and then we simply want the width and the height. This width and this height, we want to make sure it is clamped within certain valid values. So I'm going to make some constant static values that will define the minimum and maximum. I'm going to call this min dimension. Right now I'm just kind of picking some random values. Let's just say the minimum is 64 and then the max dimension will be 2048. That will allow for a full screen resolution. But we may want to make this 4096. That should allow for 4K if it's at 4096. Okay, let's do that. We'll allow up to 4096 and 64 for a minimum. As far as the width and the height are concerned, we need to clamp those values. So I'm going to make a utility class for our library, and it's just going to contain helpful functions for our game. This is going to be static utility. And the first one I'm going to create is this is going to be a clamp function. I'm just going to take an integer. We'll pass in a value, and we're going to supply a min value and a max. Basically what we're going to do is say if the value is less than the min, let's return the min. Otherwise, if the value is greater than the max, let's return the max. And then the last option is the value is in between min and max, in which case we'll just return the value. There we go. Now we have one more case we want to take into consideration. If the user supplies a min or max that are out of order. For example, if the min is greater than the max, then we want to do something about that. So if min is greater than max, we have some options here. We could either just throw an exception and just say if those values are not in the correct order, then we say it's out of range, or we could simply just reverse the values. I am pretty sure what I want to do is tell the user that you supplied values that were not in the correct order, and so it'll just throw an error. And let's provide a little bit more information here. We'll say the value of min is greater than the value of max. That looks like everything we need for that. And I can tell right away that I'm also going to want one of these functions for floating point. So let's write another one of those. And I'm actually just going to change these values here to just float. So now we can go back to the screen class. Let's go ahead and clamp our width value to be, our width and our height values to be within the appropriate dimensions. So we'll call the utility class. We'll clamp the width by the min dimension and the max dimension. And do the same thing for the height. There we go. Now let's save a reference to the game class. Check for null. And then let's create our render target. It wants the graphics device. We'll get that through the game class. And then simply supply the width and the height. So I do want to give access to the width and the height. So let's give some properties here. We'll simply return the target width and the height. Let's implement the disposable function. Since I'm not going to have any native functions here to dispose of, it's going to simplify the way I dispose of my items. If it's already disposed, let's just return. Otherwise, let's dispose of the target. And then we'll set is disposed to true. The next thing I want to do is I want to be able to set the screen as the render target, and then I want to be able to unset the screen as the render target. Okay, so when the screen is set, it's going to do all the rendering here. And when we unset the screen, it's going to do all the rendering directly to the back buffer. So let's make a function called set with no parameters, and we'll make a function called unset. And we're just going to tell the graphics device to set the render target to the target in this class. And then when we want to unset, we tell the graphics device to set the render target to null. And when you set the render target to null on the graphics device, it tells the graphics device to use the back buffer as the render target. I also want to create, now that I look at this, I want to create a flag that will tell me if we are currently set or unset. So we'll just put is set here, and we'll set that to false. Set it to true. Set it to false. And then we can just do some checks. If it's already set, let's just throw an exception. We'll just say that the render target is already set. And then down here, if it's not set and we try to unset, we'll say the render target is not set. There we go. And that'll just hopefully allow us to eliminate bugs in the future by giving us an error saying, hey, you're trying to set it twice, or you're trying to unset it twice, or it was never set, so there's no reason to unset. And then I need one or two more functions. The first one's going to be a present function, which will actually display what we've rendered. And we're going to bring in the sprites class for rendering. Do I want to check the sprites class for null? Yeah, let's go ahead and put that in there for now. Alright, next we're going to tell the sprites that we want to begin drawing. Now we want to enable texture filtering here, so I'm going to set that to true. And the reason being, when we do stretch this over here, I want it to have a nice smooth look to it. Maybe we could even give the user the ability to decide if they want texture filtering or not. We could put a boolean here for texture filtering and just set it to true. Okay, let's put that in there. That looks good. And then we end the batching just to display what we have. To actually draw the render target, we're just going to pass in the render target as a texture. And then we need the source rectangle to be null because we're going to draw the whole thing as the source. The destination rectangle is now the big thing we need to worry about. Let's just put destination rectangle here as a placeholder, and the color will be white because we're not going to change any of the colors. So now we need a function that will calculate the destination rectangle. I'm going to make a private function here. It's going to return a rectangle. We're going to call it calculate destination rectangle. And we can do this. We can say rectangle will be equal to the calculate destination rectangle. Okay, so this function's all done. The last thing we need to do is just implement this calculate destination rectangle. The first thing I want to do is figure out the difference between the aspect ratio of the user's back buffer and our screen that we've created. We need to figure out which one's wider. Is this wider as far as aspect ratio goes? As a ratio, is this wider or is this wider? Let's go ahead and get the back buffer through the graphics device. Okay, the first thing we want to do is get the actual size of the back buffer. And so I'm going to store that as a rectangle. We can get the information through the game class and the graphics device, the presentation parameters, and the bounds. The back buffer aspect ratio is now going to be the back buffer bounds width divided by the back buffer bounds height. These are integer values, and so I need to cast this into floating point, so I actually get a ratio. I want the screen aspect ratio, which will just be this screen width and this screen height. And again, those are integer values, so let's cast that into a floating point. Now we can decide which way we want to draw. In this case, the user's display or window is wider than our screen, and so we're going to draw something that looks like this. If the user had a display that looked something more like this, and we tried to stretch onto here, then it would stretch to look more like this. Let's do a comparison to see which is wider. So the first one we're going to do is say if the user's back buffer is wider than our screen. The way that looks is we'll just say if the back buffer aspect ratio is greater than the screen aspect ratio, then we'll do this. Otherwise, if the back buffer aspect ratio is less than the screen aspect ratio, then we handle stretching the other way. Okay, so here's the case where the back buffer aspect ratio is greater, and here's the case where the back buffer aspect ratio is smaller. Back in our code, I'm going to make some default values for where and how big this screen is going to be. The default values are going to say the aspect ratios are equal. Even though this may be this size and the screen may be this size, the aspect ratios are equal, so we just stretch it to fit here. So we're going to position it here and stretch it to be exactly the same size. If that's the case, it's very simple. We'll just make the default, so the position, the RX position or rectangle X position, will just be at 0. The rectangle Y position will be at 0. The rectangle width position will just be the width of the back buffer, so that'll just be the back buffer bounds width, and then the height will be the back buffer bounds height. And if that happens, none of these conditions will be true because it'll be equal, and so we'll just go on through, in which case we're going to define the rectangle result will just be equal to Rx, Ry, and then the R width and the R height. And then we can return that result. That'll be the simplest case where the aspect ratios are equal. We just create it like that to equal that and then pass it on through. It's looking for integer values, so we'll just simply cast these to integers. Okay. If the back buffer aspect ratio is greater than the screen aspect ratio, we end up with something like this, in which case we need to figure out how wide we need to make it first, and then that'll tell us where we need to move the X. Now the height is just going to equal the height of the screen, which makes that part really easy. So the Y will simply be at 0, and the height will be the height of the screen. In our code, we already have that defined. The height is defined there as the height of the back buffer, and the Y is at 0. So we just need to figure out Rx and Rw. First, let's figure out the width. The width is just going to be the height, and we're going to multiply that by the screen aspect ratio. What that will do back over here is say, take this height here, multiply it by the aspect ratio we have between this width and height, and that should give us this new width that we need. Now that we have this width, we can simply divide the screen in two and move it back over this way by half of the width. The way that looks is our X position will now be the back buffer bounds width divided by 2, and then subtract out our new rectangle width divided by 2. And that'll get the correct X position. And we can actually simplify this by combining the fractional divide. So we just take that out. We do the subtraction first, and then do the divide. I'm going to make sure we're casting this to a floating point. So now the next case is down here where our render target is wider than the back buffer we're displaying on. If that's the case, now we just do the opposite. We're going to calculate the new height will be the rectangle width divided by the screen aspect ratio, and then the rectangle Y position will be equal to the back buffer bounds height minus the new rectangle height we calculated, and divide that by 2, and that'll give us our position. That's our calculate rectangle. We have our present. I think we have everything we need now. Let me get rid of some of these things they added in there because I don't need any of that. That looks good. Let's test it out. Let's create a new screen. Here we will create the new screen. Pass in the game. So for width and height, let's just say we want a 1280 by, actually we can do 640 by 40, just like our example. There we go. Down here, let's tell it we want to set the screen. So now our screen is our render target. And then down here we want to the screen we want to unset, so we're now back to drawing on the back buffer. And then we want to present the screen and pass in the sprites class for rendering. The only other thing I think I may want to take care of is clear the graphics device to something when we present. So let's go back into the present class of the screen, and let's actually clear the back buffer here. So through the game class, we'll go to the graphics device. Let's clear to some default value, probably just black. We may want to do hot pink just to, that'll show us where the actual back buffer is being displayed. And maybe what we can do is just say if we're in debug mode, we'll do this. Otherwise, okay, so there's debug mode. If we're debug mode, we'll draw hot pink. If we're not in debug mode, we will just do black. That looks good. We're calculating our destination. Oh, and that's not else, that's just else. There we go. Okay, so now if this is working correctly, it should draw everything we were doing before, but in a special render target for us. Okay, there we go. That looks good. Now we have a screen that is 640 by 480, and we are drawing our sprite onto that screen, and then it's stretching the screen to fit our window. And we can do some more testing on that to see if it works. Let's change the actual resolution of our back buffer. And we can do that by going through the preferred back buffer width. It will now be, let's just pick some numbers. Let's say 1280. And the height will be like 600. I'm just kind of picking some random values. And then we need to tell it, do we want to apply changes? And so now we should have a newly sized screen. There we go. So this one's a lot wider, and you can see it's stretching to fit exactly into that window. Now let's change this around. Let's say we've got a 600 or like a 400 by, and then the height is a lot taller. We'll just say 800. So it's twice as tall, and so it should fit the other way now. Okay, there we go. So even in this type of back buffer where it's really tall and thin, it fit in that window.